performance. I mean, how this new technique could be considered as a low-cost preventive maintenance element. So Tobias PANWINKLER from Boston has completed this economic study. He will present the main conclusions here. Tobias, please.
Okay, so good morning from my side also. My name is Tobias PANWINKLER. I'm, like my colleague Bastian before, from the German Federal Highway Research Institute, which is then abbreviated BUST. And first of all, also let me thank you again that we had the opportunity to present our findings here at this conference. I think it's a very good platform to show what we could already find out with our research. So now it comes to my part. My aim was to test, after my colleagues already had the idea for this mixture and brought it to reality, brought it also to on the road, and then analyzed the life cycle. It was my task to answer the final question that is always asked first: is it really cost effective, and what are the costs? So to answer this question, we used the concept of a life cycle cost analysis, and this will be the first part of my presentation, giving you a bit of theoretical background of this concept. After this, I present you the variants we did, because we compared several variants in order to see the cost effects. And then I go into detail and show you the different costs we analyzed and included in our assessment. Yeah, and I'll close showing you the results and giving you also a small short conclusion about this. All right, so I told you our concept was the life cycle cost analysis. Now what's it about? The idea is not only to evaluate the costs that come from the construction of a building, or in this case the road construction, but also take into account the whole lifetime of the construction, meaning not only the investment costs but also consequential costs. As we did this for a certain period, for a fixed lifetime, we had the chance to had several alternatives that we could compare, and this is why we chose this this model, because in this way we had to we could compare variants with this new heel road mixture against common porous asphalt mixtures. Now, as I said, we didn't only took into account the construction costs, but all the costs that came within the whole life cycle, and basically we could divide those costs into two big groups that were the costs that had to be paid by the road authority, and that are the costs that burden for the people, basically the road users, and also the society as a whole. To go in detail, road user costs can be divided into the costs of the construction itself. That means the costs for all the construction items, the construction layers, and then also general construction costs, operating expenses, and also the risk and profit that one company has when applying this new mixture. Then there comes the maintenance. That is an annual cost that has to be done every year, like cleaning and so on. And third point, and this is really the important point for this project now, is are the costs for repair and renewal measures, meaning in our case then either remove the surface layer or healing it. And then to have all costs implemented, also salvage value has to be calculated, which we also did by calculating the costs that would appear if we remove all the roads to restore the original conditions, meaning metal again. On the other side, we had then road user and social costs that could be divided in 3 groups. And first are costs for road user because of worsening surface conditions, and second could be road user costs caused by the measures that had to be done to repair and renew the road. And the third group of costs are social costs that burden for the whole society, like noise, pollution, and climate costs. Now, as we compared several variants, those road user costs by worsening surface conditions and also social costs were the same for all variants, and therefore we put them for insignificance for the comparison of those LCCA analysis, because what we really wanted to know is what are the costs that are caused by the measures taken. So this is why we put them into insignificant for this case. Now then we had to define where do we install our variants, our heel road and our comparing asphalts. So we had to define a virtual theoretic road, and therefore first we had to define the construction of the road, where both the heel road and the comparing asphalt had basically the same construction with a 12, beginning with a 10 centimeter frost blanket course, and then crushed rock base and asphalt base course. And the only difference in both variants then was the upper asphalt surface layer, where the heel road asphalt had a 5 centimeter heel road wearing course, and the comparing asphalt had a 5 centimeter, let's say, common porous asphalt, which basically was the same mixture but without the induction heating fiber. Then, as my colleague already mentioned, we thought about where to implement the heel road asphalt, because the heel road asphalt is invented to prevent or extend the lifetime of roads that are heavy frequented by especially heavy vehicles. So we thought we will calculate this by only installing the heel road asphalt on the main lane of motorway. And because we didn't know the consequences for the other lanes, so we decided to calculate 2 different scenarios, one with 1 overtaking lane per direction and one with 2 overtaking lanes per direction. And therefore we chose the 2 standard cross sections with, which are given by the German standard, and those are RQ31 and RQ36. So now we had 2 variants of the surface with the heel road and comparing asphalt, and we had 2 variants with the cross section with 2 and 3 lanes. And this gave overall 4 variants that we calculated for with 4 different life cycle cost analysis. 1 with heel road asphalt and 2 lanes, 1 with heel road asphalt and 3 lanes, and then comparing asphalt with 2 and with 3 lanes. Also already given by my colleague before, we had the analysis period of 30 years, because this is by German standard the lifetime of the whole road construction, where the whole construction has to be exchanged. And then we set the exchange for the common asphalt to 10 years and heel road asphalt to 15 years, and we had 2 induction heating measures. Now what we did then, and this is just a table that should give you an overview, you don't have to look at all the figures now, but what I want to show is we analyzed the costs of every single layer, every item, and then summed it up for our test section, which had 10 kilometers, to generate the different costs we had. And there we could then see that heel road variants had slightly higher construction costs because of additional material, but had clearly lower costs for renewal measures because we didn't have to exchange the surface for a second time. Then we also calculated the socio-economic costs and again, just the overview of the table that shows all the different costs for heating as well as for exchange, the wearing course, where we in the end could see that heel road variants have less social economic costs because we didn't have to calculate to close the highway for the long periods, but just close it during a few hours during the night to do the healing. So overall, if we put them all into a result table, we can say that heel road variants had slightly higher construction costs, but then road user costs for the measures as well as road authority costs for the measures were clearly more cost efficient, so that in the end we can say that for our theoretical calculation on a virtual road, this was about 4% more cost effective when using heel road variants. Also what we could see, and now I come to the conclusions, is when we compare the two different cross-sections, that cross-sections with one overtaking lane had lower costs for the renewal measures, but cross-section with two overtaking lanes then had lower costs for the socio-economic costs. In the end, this equals so that, as I already said, we could say that heel road variants were about 4% more cost efficient than our comparing variants were. So what would be the outlook for the future? As the construction costs still are higher, probably there is some research needed to think about how to lower construction costs of heel road asphalt in order to get competitive there as well. But on the other hand, the costs for measures, especially the socio-economic costs, gain more and more attention. So this would be a very good asphalt then for future use. And with that, I thank you for your attention to my speech, and yeah, I'm interested for your comments. Thank you.
Thank you very much, Tobias. Thank you very much to all the speakers. So after all these presentations reflecting the evolution of the project since the very beginning to the deployment of the road, so it's time to reply or to answer your questions. So if anyone has any questions or comments, please go ahead. Or also, okay.
Okay. Firstly, thank you for all your presentations to giving update information, because I remember about 2 years ago in Prague, I remember seeing the first poster about the idea in Netherlands that it may be a new solution for road preservation. But generally speaking, after all those tests that are performed and seeing that we are already making a life cycle analysis and cost effectiveness, I still have a general question. Is it okay to compare heeled porous asphalt, as we saw in a lab test, that the porosity goes way down, to regularly aged 5-year asphalt? Is it still the same material that we are comparing, and as we as road users or engineers, because the porous asphalt has to drain the water, has to serve, will it be the same after 1 or 2 healing processes? This is again general question.
Well, thank you. This working? Thank you for the question. It's really interesting, and it is true that with this methodology we can only heal cracks, right? But of course, the bitumen is not going to be new again. For that thing, we are also working. You might be familiar with a new technology we are also developing at the University of Nottingham. There is encapsulated rejuvenators. So what we try to do with that is trying to keep the aging level in the mix as low as possible. So when we do this heating, actually the mix is as new as possible and we can heal the cracks. But it is true that with this technology we can only heal cracks, but we cannot reduce the aging. It is also true that this technology, although it consists on heating the asphalt, we are not actually increasing the aging, because the heating is very selective. It's just we don't need to heat like by conventional methods that we heat the whole mix and the aggregates and everything. So we just heat the mix for 1-2 minutes very fast, and it cools down again. So we haven't seen any affection in master cubes or in rheology in general like that. Yeah, it's also true that in the surface, normally we use porous asphalt. We have seen that is more effective than a dense mix. So in that sense, I think the technology is very useful, because for the surfaces for porous mixes is where we can actually do our best job. And another thing that I could also add is that although this technology was thought at the beginning like to heal a whole road, we have identified that the greatest potential we think it is when we target specific critical sections where we know that the damage is more prone to happen, like bending, roundabouts, bridge joints, or where intersections, where there are traffic lights, where the cars break down and speed up again. So these kind of sections, normally the damage happens before, it happens earlier, and sometimes we have to we carry out some maintenance operations in the whole road because of this specific section. So we just target these sections with self-healing material. I think we can extend the service life of the rest of the road. That even increase more the efficiency of the project and the maintenance process.
Thank you. If there is any other question related to other aspects of the research, or if any of the speakers wants to remark any parts of the presentation. Well, I guess that everybody wants to go for lunch now. Okay, so thank you very much. The consortium, thank you very much the University of Cantabria for coordinating the project. All the information of this project, you can find it in a dedicated website. It's www.hillroad.eu, and if you wish any particular, you want to get more details about any of the elements, please contact us during the lunch break. Thank you very much.
But it's still on.
Too much.
Okay. Yeah.
Yeah. You are here tonight.
relativamente cerca para lograr. No, en el mismo estado prácticamente, porque igual es el primero.
No, que no.
Sí, yo me acuerdo en el Uruguay, 500 kilómetros de luz y eso, hay que ir y volver a los 2 días de lo que sea.
Somewhere in between our hotels. Okay. There's a restaurant I investigate.